Hi everyone, I'm Shanthamathi KS, Assistant Professor of EC Department from Ganadhapati Tulsis Jain Engineering College. This presentation is about noise characterization. It includes noise, sources of noise, external noise and internal noise in detail. First, let us see about noise. So what is noise? In general, we can say any loudness, unwanted sound or any unpleasant sound we can say. But technically, that is in electrical terms, we can say noise as an unwanted electrical signals that tends to interfere with the transmission of that signal, processing of that signal, reception of that signal and reproduction of transmitted signal. So these noise may corrupt a desired message signal, and this noise can be unpredictable also. That is, this noise varies randomly with time. So we don't have any control over this. Now let us see sources of noise. So there are two sources of noise. The first one is external noise and the other one is internal noise. So this external noise is classified into three types. One is atmospheric noise, extraterrestrial noise and the man-made noise. Internal noise is again classified into 5 types. The first one is short noise, second one is thermal noise, third one is white noise, next is low frequency noise and the last one is transit time noise. So coming to that external noise, in external noise, this extraterrestrial noise is again classified into 2 types. One is solar noise and the other one is cosmic noise. Now we'll see the external noise. This external noise is generated outside the device or any circuit. The primary sources of this noise are atmosphere, extraterrestrial and man-made noise as we seen earlier. So first we'll see about atmospheric noise. So this is the first primary source of external noise. Within the Earth's atmosphere, any naturally occurring electrical disturbances are called as atmospheric noise. This kind of noise will not occur regularly and it can be caused by lightning, storms, intergalactic or other disturbances also. Now we'll see the second source of external noise, that is extraterrestrial noise. As we know already, we have 2 types here, solar noise and the other one is cosmic noise. So this noise, that is this extraterrestrial noise, is exactly originating from outside the Earth's atmosphere. We can also call it as deep space noise. This noise is originating from the Milky Way galaxies, the Sun and the other galaxies too. The first subtopic of extraterrestrial noise is solar noise. Usually from the sun there will be a constant radiation, that is noise radiation intensity. This is in a normal condition, but in some cases, that is like sunspot activity or solar flare-ups, there will be a high noise intensity. This can be occur, that is the solar noise can be occur for every 11 years. The solar noise is nothing but a sun's heat. Next subtype of extraterrestrial noise is cosmic noise. So generally it occurs due to distant stars. So from there the RF noise is getting radiated and distributed throughout the galaxies. The frequency range of this cosmic noise lies between 15 MHz and 150 megahertz, and this cosmic noise we can also call it as black body noise, and this cosmic noise occurs also from quasars and pulsars. Next is the third source of external noise, that is man-made noise. From the name itself we can say the noise which is produced by a man, that is motors, automobile ignition, AC power generating, leakage from high voltage lines, fluorescent lights and even the takeoff of airplanes. This man-made noise lies from 1 MHz to 500 MHz frequency. So this man-made noise will be more intense in densely populated area, that is in a metropolitan area and even in industrial areas. So the man-made noise which is occurring from industrial areas, we can say that noise as an industrial noise. Now we'll see about the internal noise. So the first primary source for internal noise is short noise. Where we can observe this short noise means in anode current of a vacuum tube amplifier. So this is caused by random arrival of carriers at the output element of an electronic device such as transistor, diodes and triodes. So this random arrival means the carrier will not move continuously and in a steady flow, which means it will be randomly varying. So the short noise, the total current, we can write it as I of t, that is the sum of constant current due to carriers and the short noise current. So this will be in a deterministic function. So we can represent it as I of t equals to I naught plus I suffix n of t. Next we'll see the thermal noise. So from the name itself we can say this thermal noise, it is nothing but the temperature. So this is that electrical noise generated in resistance or any resistive component. So here also due to rapid and random movement of free charge particles inside that component, then thermal noise may occur. So it was invented by J.B. Johnson. So this thermal noise we can also call it as Johnson noise. Since it is observed through that resistive element, we can say this noise as a resistor noise. So the noise power due to this thermal noise, we can write it as Vn square divided by 4R. So the equivalent noise voltage we can write, that is Vn equals to square root of 4 into resistance R, that is into noise power. So according to J.B. Johnson, this noise power is the product of the Boltzmann constant K, the temperature T and the bandwidth B. So now the noise voltage we can write it as Vn equals to square root of 4kTBR. And the noise current we can write it as In equals to square root of 4kTB and G, which is nothing but that conductance. Next we'll see about the white noise. So this noise contains all frequency in equal amount within the visible band of electromagnetic radiation. The probability of this white noise can be implemented using a Gaussian distribution. So we can say this noise as white Gaussian noise, and the noise power we can represent it as N naught. So that will be equals to K into TE. So where K stands for Boltzmann constant and T suffix E stands for equivalent temperature. The next noise in internal noise is low frequency noise. So here the frequency range of this noise is very few kilohertz. We can say this noise is also called as flicker noise. So here the noise is varied inversely with the frequency. So we can also call this noise as 1 by F noise. As the carrier density fluctuate, the conductivity also fluctuate. So this will produce a fluctuation voltage drop when a direct current flows through a device. So this fluctuating voltage is called as flicker noise voltage. The spectrum density of this noise increases as the frequency decreases. So they are inversely related. The next noise is high frequency noise. So this noise is also called as transit time noise. So the transit time means the time taken by the carrier to cross a junction. Okay, so that is the changes in a stream of carriers as they travel from the input to output of a device produce an irregular and random variation noise. So in such conditions, some of the carriers may diffuse back to the source. This gives rise to an increase in input admittance, the conductor component of which increases with increase in frequency. Thank you.